Wow, it's quite a huge room here. I'm super excited to be here today. And before I even start the talk and everything, I want to say a couple of warm words to our organizers, Front-End Love, for making this event just real. You know, I was really looking forward to go back to Amsterdam when I used to live for quite a while and have an opportunity to share all these insights about upcoming React Native architecture with the community. And thanks to these folks, this came true. So thanks. Aside of this, it was quite a while when I was here, and many things have changed, so did React Native. Now we have a new architecture that is being actively developed by Facebook. And today I'm going to try to do my best to unveil some secrets underneath this new architecture. But before I'm going to keep rolling with this, I want to say a couple of words about the talk in general. Basically just make a small disclaimer. This talk has kind of no strings attached to Facebook. It doesn't represent official opinion on Facebook about this architecture whatsoever. So basically, please consider this as absolutely detached topic. That said, let's keep rolling, right? How many people here ever worked with React Native? Please just raise the hand. Oh, wow, that's way more than I expected, to be honest. That's amazing. So probably you already know this diagram. It's probably one of the most known diagrams about the way how React Native works under the hood. But I'm still going to repeat this because obviously lots of people don't know what it is. In React Native, in general, we have kind of two realms, a JavaScript realm and a native realm. So if you think of it, JavaScript realm is something that we already used to work with, right? Like we probably came from other JavaScript technologies, frameworks, whatever. So we know how to write JavaScript, and this part is not really like a miracle or mystery or whatsoever. But then we have a native part. And this is quite an interesting part because, well, I don't know about you, I never ever touched native development before I started to work with React Native. So for me, that was just like a black box. And let's keep it like this for a little while. What is quite intriguing about React Native is that it allows you to connect these two absolutely different realms, JavaScript and native. So how does it do that? As you can see on the diagram in the middle, there is a tiny piece called bridge, and these two strings going back and forth. So the way how it works, it's easier to explain this on an example. For instance, if we want to call a native model that is implemented on the native side, obviously, from JavaScript, what we need to do? We require native models. We're saying okay, native models like something, please open a camera or something like that. And then what's happening, there is a message that goes to the bridge. It gets enqueued to the bridge. So mind, this is actually quite important. Bridge works asynchronously. So we enqueue some messages, and at the moment when we have capacity to process these messages on the native side basically dequeues some messages from the bridge and then starts processing them. And then, of course, if we need to send something back, it goes exactly the same way, but other way around. Basically enqueues the response to the bridge, it again gets queued, and then when JavaScript has capacity, it takes it from the bridge and it gives it back to us, developers. And this sounds like a pretty great idea, to make this bridge and make the thing to work asynchronously, right? Well, I will try to kind of pick this idea a little bit by introducing this example. Consider that we have a React Native application, right? And we probably, every single person who developed React Native application probably had to deal with lists. And probably we're talking about some big list or whatsoever. So many different rows. You know, rendering the entire list will be quite unperformant because memory and stuff. But what if we can just render a part of this list? This technology called virtualization, and it's embedded into React Native lists by default. So React Native tries to virtualize your list without even you knowing about this, unless you really want to. So what is happening? We only render the part of the list, and all the rest, basically all the rows above and below the viewport, they're not really rendered. They just like appropriately sized blank rows or whatsoever. So at the moment when you scroll, you see this nice scroll bar that shows you the proper size of the list. And that's fine, because at the moment when you start scrolling, new elements appears in the viewport, and at that moment of time, we try to render these elements. So if you think about this from the perspective of this previous diagram, we can try to map this logic to how React Native works. Let's try to do that. But first, some water. Okay. So how are we going to do this? Let's imagine this. We already have a list. It's rendered. We have a viewport. Cool. Now we start scrolling this list. What is happening? The scroll event is a native event because we interact with a native view. It originates on the native side. Then it needs to render something, right? Because like it's a list. So it goes to JavaScript. How it goes to JavaScript? It goes through the bridge. It enqueues a message saying like, hey, JavaScript, can you please render me like these rows so I can display it? And JavaScript, when it has capacity, again, it dequeues it, it renders stuff, it queues it back, it goes through the bridge, goes back to the native, and you see it. What's the problem with this? You obviously might have a case, especially on the low-end devices or something like that, or if your JavaScript thread is busy, that at the moment when you start scrolling pretty fast, you start seeing blank rows. And that's because at the moment when you scroll, sometimes this communication, this asynchronous communication is not just fast enough to render everything and send everything back so you have like everything in time. And that's why for a fraction of a second, or maybe for a second, you have this blank row and then bam, it swaps to the real row. And with current architecture, like many smart people, way smarter than I am, try to solve this. And apparently we still have this issue. But with the new architecture, it might be solved. With the new architecture, we'll be able to do these things in a synchronous fashion. And I will explain you how. So now, when we think about this idea of like asynchronous bridge, asynchronous communication, let's try to think if we can actually do better, because there are many other systems that had similar issues, and they managed somehow to overcome them. Let's look around for the inspiration. And for me, it's like previously web developer, it will be pretty easy to relate to browsers. So what we have in browsers is basically, we have JavaScript runtime, where we run our JavaScript, but this runtime is extended by custom C++ functionality. Some things like set interval, set timeout, fetch, and like many other APIs that we use in the browsers, they're not really implemented in JavaScript. They're not even a part of the language itself. They're part of the thing that extends JavaScript runtime and basically exposes references to C++ functionality from JavaScript. And that works in a synchronous fashion, right? And it's pretty cool. And this is kind of something that we want to achieve in React Native, right? If you think of it, we can try to implement somewhat very similar to this in React Native. Before we go any further, just to make sure we're on the same page, this is not yet released, and this is not yet public whatsoever. Some parts are already in the React Native open source repository, but there is no real way how you can connect these dots straight away. However, this is incredibly interesting because the way how it's going to work, going to change the way how we write our native models and connect things together. Okay, without any further ado, let's start talk about the way how all the things are connected. And I want to kind of warn you, because this is going to be quite technical. But please try to bear with me. I have some nice diagrams to illustrate this. Let's talk about like the way how browser works with all this like custom extensions and everything. We basically have a browser engine that contains under the hood JavaScript engine. In React Native, JavaScript engine is JavaScript core or simply GSC. But there are many others, right? We have Chakra core, we have V8, we probably have something else. And what is interesting about this is that React Native, even though it's pre-bundled with like solutions for Apple and Android, well, for iOS and Android, sorry. So when we have this, it doesn't mean that React Native is only capable of managing these two platforms. There are lots of solutions out there, like for Microsoft, for something else, and you can write your own. So theoretically, you're not really binded to work with GSC. So theoretically, there might be many other JavaScript engines out there. But let's think about developers for a second. If we say you can replace GSC with like whatever you want, then it means that developers will have to write their models in a way that they're targeting these like specific browsers, JavaScript engines. And it's quite tedious, right? Because like, first of all, you will probably have to do it in C++, and I don't know about you, I don't know C++, and I don't want to learn it. But still, we kind of need to find a common ground there, right? So what smart folks from React Native and Facebook in general did, they introduced an abstraction, something that is behind the question mark here, is abstraction that basically covers up all these underlying APIs of the JavaScript engines. And again, in React Native world, this abstraction is called GSI. So GSI connects your native models to the JavaScript runtime. So it all happens on the native side. And there are some implications of this. For instance, GSI is written in C++. So for us, like as React Native developers, or maybe even web developers right now, it's no-go, like it's not really actionable. We don't want to write this. But we don't mind write native models, right? Or at least use someone else's third-party models and connect it. So we need somehow to connect our native stuff to GSI, because we don't really mind how GSI connects to all these underlying JavaScript engines. This is fine. So in order to connect your native side to GSI, we use a thing so-called GSI bindings. This is a very powerful concept, and we're going to talk about this just in a second. First of all, I'd like to show you how all the things work together with the new architecture, right? So again, we still have our JavaScript. We can call GSI directly through JavaScript because it extends JavaScript runtime. And we also can do it through React Native because, for instance, every single time when React Native gonna call something like a render method and it needs to render a native view, it's gonna go through the GSI again and then go to the native platform and execute some code. Of course, this thing happens synchronously. And optionally, you can return back a promise or something like this. So you can make it asynchronous, but it also can be synchronous, which is a competitive advantage comparing to the previous bridge architecture. But one thing though, like I said something about C++ and stuff, and we need to work around this. Let's think about these GSI bindings that I mentioned. What are they? They basically like a class that maps whatever functionality you have in your native model to something that you expose to JavaScript. Because sometimes you might be like, okay, I'm going to trigger this third-party library, process the result somehow, and then just going to expose it back. And GSI is basically connecting your implementation of the native models to the runtime. It's literally like one-to-one. It's something that needs to be there just to expose your models. So why we cannot just generate these GSI bindings? If you think of it, what do they need to know? We just need to know about a few small things. For instance, we need to know about the signature of the underlying native model, and we need to know something about types. And this is where the trick comes in. We cannot know anything about types because JavaScript is a dynamically typed language, and there is like no way we can just use JavaScript to generate these types, right? Because like how would we? But we can do one neat trick. We can switch JavaScript to something like TypeScript or flow type. In this particular case, we will have so many cool new things. We will have types by default. So that implies that we can compose a tool, so-called CodeGen, that's going to basically get these types, generate something so-called React Native schema that describes your native models or your native components. It will describe all the types that you have there. It will describe all the properties, like if they're mandatory, if they're not mandatory, optional, not optional, and stuff like this. So it will cover everything. And based on this schema, we will be able to generate GSI bindings that we really need. This is quite smart because aside of this, you can generate not only a tiny part of the new architecture, which is GSI bindings, but you can also make sure that you can generate things like, for instance, protocols for Objective-C or classes for abstract classes for Java. Why do we need this? Well, because now when we have types in our JavaScript environment, what we can do about all this, we can now make sure that JavaScript, or like TypeScript flow type, going to be source of truth for our JavaScript to native communication. We can make sure that whatever we implement in native side, we can basically make sure that it complies to JavaScript. What we have right now, if you think of it, we can create React Native models. We can create Java implementation with like a function that takes a string. In Objective-C, the same function will take a number, and from JavaScript we can send an object. And like, it doesn't give us any errors till we actually hit this, this branch in our code. So unless we actually call this functionality, we will never know that it's broken. With the new architecture, when we can generate all the things in advance, we don't really need this, because what we can do, we can make sure that everything is compliant with JavaScript at the build time. And this is one of the really cool advantages. So if you look at this revisited diagram, what you will see? You will see that instead of JavaScript, we have TypeScript or Flow. Then we can run CodeGen to generate GSI and all these Objective-C protocols, Java class, all the thing. And then at the end, we have our native models that can consume this generated GSI and then implement this Objective-C protocols or extend Java abstract class. Which means that if we go for this way, that at the moment when we run our application, and let's say our native part doesn't really comply with whatever we declared in JavaScript, it means our application just won't build, which is quite amazing. We will know that we have an error in our code base in advance, even before running our application. It will give us all those benefits that native developers have. And it's incredibly interesting. If you consider going like further down this line, we can basically frame 4 different core advantages of this new architecture. Of course, the very first one would be compile time type safety, which means that we will never ever encounter a case that there is application, it's running, and at the same time, whatever we implemented on native side doesn't comply with our JavaScript interfaces, which is, again, quite cool. The other thing, we're going to have safe over-the-air updates. For those who are not aware of this, like, you can think of code push, for instance, right? You created your application, you bundled it up, you send it for the review, it was approved, it hit like Google Store, like Apple Store, like whatever, it's there. And now you figure it out that like the copy is like not right or something is off, and you want to send another update to fix it. But then accidentally, you change something in the signature of the function that connects to the native code, and bam, you have your application broken. And of course, it's bad, and we need to figure out like how we can solve this. It's pretty hard to test this kind of things. So now, when we have this CodeGen and we have schema that describes all the types and everything, we can create a tool that's gonna basically div these schemas. The schema that we committed in our build, and the new schema of the JavaScript bundle that we just built. So at that moment of time, we can create something like a CI flow or whatever that's gonna compare the schemas and tell us, oh, you know what, you actually introduced a breaking change, so we're not gonna apply this, this CodeGen push. Oh, sorry, CodeGen push. We're not gonna apply this push. It's not gonna be public. So again, at a build time or a CI time, we can cache all the things and prevent these terrible things from happening. The other one is a startup time. So with the new architecture, we will be able to eliminate a part of the runtime overhead. For instance, what is happening now, imagine you have many native models in your React Native application. What is happening at the startup? We have to load like all these models into memory, because what happens next? React Native iterates over all these like models that we include in our build, and then it pulls out all the exported methods and classes and everything, and then it transfers over the bridge to JavaScript to generate those interfaces that you can access when you require native models from React Native. And this is something that is quite unnecessary if we consider the new architecture, because now we can generate the things again at the build time. So many things that we currently do at the runtime because there is no better way will be there just for us at the build time. And another last but not the least part is about consistency. So what I mean by consistency? Now there is no source of truth. We can write our native models. We can think like, okay, we have like application that targets two platforms, iOS, Android. And what's the problem with this? We don't know. Well, in my personal experience, there is always one platform that is leading. That is basically ahead, and like the second platform tries to catch up. Like someone is just like, okay, we're focusing on like iOS, and then like Android will come later, like we're gonna tweak it somehow. But with this thing, at the moment when you declare something in JavaScript, in TypeScript or Flow, we are forced to have this feature parity on underlying platforms. It's not like now we have the source of truth, and the source of truth on the client side in your hands. So there will be no doubt anymore, like, okay, like we want to have like iOS as a source of truth, or Android as a source of truth, or JavaScript as a source of truth. No, we can just like write our code as we do daily, and we will have all the strict rules embraced for us by React Native team and React Native new architecture. Well, I know it was probably too much to swallow at the same time. Yeah, I just want to start rounding off and wrapping up, saying, look, this talk might be not applicable for you just straight away. But keep in mind that like sometime from now, when all the things will be open sourced, there will be a new way of writing native models. And it's quite important, in my personal opinion, to share this information as soon as possible so everyone can start looking into this, getting more information, get involved into things like discussions and proposals on the GitHub, because it's a public information, but no one looks at this because it's not something that we can use like straight away. So bear with me, check it out. If you have any questions about this talk, this new architecture, or something else, please hit me up on Twitter. I'm super responsible about, well, responsive, sorry, to these kind of questions. And yeah, thank you very much for your time.